Welcome back to Rust smart contracts. Today we're exploring token smart contract with custom logic, whitelist. Let's start. We are building a complex token, that's why our use section is large, because we must manually import every piece of official standard. We are not just grabbing random tools, we're importing only specific traits and structs. And let's start with fungible token metadata. It's to define a token public entity. Name, symbol, icon, fungible token metadata provider, trait, which wallet query to display this information, and the last one is just required constant. After that, we move to fungible token, or more famous as NAP 141 standard. Fungible token is core engine, fungible token core is for transaction logic, fungible token resolver is for safe fund refunds, and after that we will move to the storage management. This standard is essential for security, also to register users. We'll talk about it a little bit later when we'll talk about interaction with the smart contract. And the last one, there's a chosen storage collection. We are set up lookup set and lazy option. Lookup set for custom security list and lazy option is for efficient storage of metadata. Okay, let's move to the public struct. Here is a token we fill by fungible token. Metadata, as I said before, we are writing lazy option. For owner ID, we'll store the single administrator who controls the entire security feature. And our whitelist, as you can see, we use lookup set, and it's much faster for checking if an account is present than iterating through a Rust vector. Let's move to initialization. As you can see, here we have two init. The first one, new default meta, is responsible for metadata information like name, symbol, icon, etc. And the second one is a new one, is the main one, and responsible for other logic of our token smart contract. Let's start with the new default meta. Here you can see the owner ID, the administrator, the main one of our smart contract, the total supply. Here you said how much token do you want to publish. And after that, we have fungible token metadata. Here we have specification, the required constant name, symbol, icon, even we have reference hash, and decimals is by default 24 because 1 year is 10 in the power of 24 octonier. Octonier is the minimum amount that's available in the NEAR protocol. After that, let's move to the new. Here we also have account ID, total supply, but also metadata. One fact, you don't need to initialize two functions. So you don't need to first initialize new default meta, and after that new, you just can choose one of them. So here the first line that we write that check if it's already initialized. After that, we check if the metadata is valid without any arrows. We moved to token, metadata, owner ID, whitelist that we also initialized here. After that, we are doing the register account. So we said that our owner ID is the main account of our token smart contract. After that, we are doing internal deposit that creates the initial supplies of tokens. And the final one is we do the emit of events of our fungible token and return all the strike by this. Okay, let's move to the full standard implementation. We copy this implementation blocks directly from the official NEAR and SDK examples. By doing this, we gain all the security and functionality. Impl fungible token core, this engine of the token, responsible for all transactions. This block includes the essential method like FT transfer and FT balance off. After that, it's go fungible token resolver. This block is the safety net for cross-contract calls. It implements the FT resolver transfer function, which automatically runs after token is transferred to another smart contract. Its entire purpose is to check for failures and safety refund funds if the external contract call didn't execute correctly. So just protecting the user assets. Implement storage management for contract. Here is a defines a function like storage deposit. It's ensure compliant with storage management standard. This mechanism is crucial for our security. It requires new users to pay a tiny deposit for storing the space for token balances. It just protecting our contract from spamming accounts. And the final one is fungible token metadata provider. Is just the final block implements the FT metadata function, and it's official function that all wallets and explorers carry to read and display the token's identity. Its name, symbol, and icon image. With all the standard boxes checked, import, we can move to the most important part of our token smart contract, the custom logic, whitelist. This logic that defines the restricted nature of our token. Whitelist add. We mute our struct, so we write mutable self. After that, this function takes the account that we want to approve. And let's check our first line. It executes the most critical check if it's the owner of the smart contract, because only owner can modify the whitelist, add the people to the whitelist. So if you're not owner, it just will provide you an error. And the second line, the final one, is just basically to insert, to add the account ID to the whitelist lookup set list. Thanks to lookup set, we don't need to a manual double check if its account ID already exists in the whitelist. And let's go to the withdraw tokens. Here also we mute our struct because we add the accounts to the whitelist to be exactly removed. And first we get the signer ID who wants to withdraw the tokens. After that we check if their account who calls these functions in the whitelist, so if the owner approves this person to get the tokens. So if not, you're not in the whitelist, it will be not panic, it will provide an error. After that, first we remove the person from the whitelist. It's very important. That's its first action. After that, we provide the withdrawal amount. As you can see here, we provide the JSON format. After that, we do this internal transfer. We send money from the owner ID, from the administrator of our account to signer ID, the person who wants to withdraw the tokens, the amount of tokens, and do we want to add some memo? I write none, and that's all for withdrawal tokens. Okay, let's interact with our smart contract. For this, first we need to add one library, is near contract standard. After that, we need to deploy our smart contract. I created a separate account token smart contract testnet. After this, I will do the initialization. I will do initialization by new default meta functions. And for this, we need to write the arguments as owner ID. I write the same as our token smart contract. And also to add total supply here, I added 10 tokens. And also, as you can see in the total supply, the amount in the brackets, because we use JSON format, and that's why it should be in the brackets. Yeah, we successfully initialize it. Okay, let's try to initialize it one more time, so it should provide an error. Yeah, it provides an error because we cannot initialize it 2 times, and if you even choose a new function to initialize, it also provides you an error. Okay, right now I would like to do the whitelist add, but right now I would like to do it by sign as by another account, not our owner ID. So it should provide an error, because only the owner of our smart contract can add and modify a whitelist. Yep, we got the error. Okay, right now I do it correctly, signed by our token smart contract, and as you can see, it's successfully added. And right now, let's do the withdraw token. Yep, and here we got an error, and it's totally correct. Because, as I said before, we use the storage management for safety and also to register people, to register users. Near protocol do it from spamming accounts, and to be registered, you need to pay a tiny fee, 0.00125. So it's even less than transaction cost. and it's around 0.3, 0.4 cents, so it's super tiny deposit. By the way, if you have any error problems with the code or you understand something, you can write in the Telegram chat of developers of Near and they respond super quickly. I remember that one time in 2 a.m. I having a problem, an error with the code, and they respond me like in 2 minutes. So I recommend you to join the chat. Okay, let's go. So for this we need to write the storage deposit function to store our account. By the way, you can provide the deposit not only from your account that you want to add to register, you can write it by any other account. So we add whitelist account to registered accounts of this token. Right now we should do the withdraw token, and right now it should be successfully. Yeah, it's successfully. And right now let's try to do the transfer token. So for this, I will write transfer token from our token contract to our whitelist token, and I will send one token. Oops, I forgot to write the sign S between 0neo and token test smart contract.testnet. I quickly change this. Okay, here I have one more error because our function is payable. So we need to add the sum amount to the contract. And by NEP 141 standard, it should be 1 octonier, the minimum amount of nears that you can have. So yeah, let's change this error quickly. Send. I'm sorry, I add accidentally 2 extra zeros. Let's change it. Yep, right now it's totally successful. We successfully send the token to our whitelist account, and right now let's check the balance of our token smart contract. It should be 8 because one token was withdrawn by withdraw token and another was transferred to whitelist, and our whitelist account should have 2 tokens. Let's check it. Yep, we have 2 tokens. Perfect. And let me say about the alternatives, how to create a token smart contract. One of the most easiest is just go to the docs near in the using fungible tokens. I will provide the link below in the video. And here you just can write the token name, token symbol, supply, decimals, and upload your image. You just need to connect your wallet. And if you want to create a token by the code, we have another variations. If you have ever do the smart contracts, for example, on the Ethereum with the Solidity, you may be familiar with ERC20 format. And basically it's similar to the ERC20 format. Here it's like super short code where you just write the symbol, name, and decimals. And also you can provide some extension to this smart contract, but people on the Near protocol rarely use it, but it's also possible. It's totally secured and provides all functionality of the fungible token. That's an advanced token smart contract. Today we'll learn how to satisfy every NEP 141 requirement with our custom logic whitelist. Subscribe and like this video. See you next time.